So that's where skill atrophy is going to be a major concern, because the junior engineers who are going to join, they get overused by the LLMs and the auto code generation of auto generation of all the artifacts. They might lose that experience of learning technology from scratch. So that is a major concern. And accountability. Who is going to own AI generated bugs? People might say, I did not generate, it was written by AI. So all these are common concerns. I believe most of you in this group agree with what I've been talking about. There has been a concern, and that is why I believe we are here to see how we can structurally solve these problems. Okay, this is add on to what we saw earlier, like because we use a has a speed, like you give a prompt, it generates like within 10 minutes, you can even build a web service that can be up and running and serving you. But the problem is it has the speed, but it does not understand your actual intent. Without what you start with a vague prompt, you get it done, but it might not capture every aspect of what you actually want to build. Without a proper structure, without a proper rule, proper guardrail, whatever we try to do with AI, if it lacks clarity, it is going to fill all the gaps with all the assumptions, with all the learnings from the World Wide Web. It might cause a lot of problem, especially for us, because we are the ones who have to question all the assumptions and the lack of clarity in the products. So yeah. Another area is that so A amplifies both productivity and ambiguity. So whatever intent you have, you want to start with it. Let's say you want to build a framework, it is going to increase the productivity. You can build a framework in a day, but the same happens with the ambiguities, right? When you are not clear of how to handle your multi-threaded test cases, how to scope your variables, and you leave that part to AI to guess, you will lose the intent. You might find the bug, like maybe when you actually implement a test case which is having issues with that design pattern. So whatever error, that also get amplified. So without a proper documented recommend of what you actually want, and if you start, then your productivity will also increase. Same goes with the error as well. It also get amplified 1,000 times, and the cost of fixing it is going to be much higher. So all this, why I have been repeating is one thing we are talking about how we structurally guide AI to do the task for us, rather than letting AI drive you. Because most of the times, that's what all the vibe coders would have experienced, right? You have a problem intent, you go start with it, AI suggests something, then you get dwelled into what AI is suggesting rather than what you want. Then you keep iterating with AI, and with the same thought process that AI is suggesting you, you get biased. You generate a code, and it might produce the output that you want, but it might not capture the actual intent, actually what you want to build. In many places, it might be missing. So that's where the AI first technology is basically it's AI first is not exactly AI only. So that's where the methodology comes into place. You have to have systematic validation at each step. You have to have a proper templated workflow, skills driven with proper rules and guidelines in place. That way, you will never let AI creep up the scope. It will not go beyond the boundaries and do things that is not intended for you. Okay. So before we talk about spec-driven, right, I want to touch base on these two concepts, which is very essential, and this is what most of us are in this phase where we do a lot of vibe coding, and how prompt engineering makes it bit better than what you get as an output from vibe coding. So I believe most of you here has been a vibe coder here, uh, and this is what vibe coding basically means. Like, you start with an intent, you do rapid iterations, you use you have so many agents like the Cascade or Windsurf. Man, it's very difficult, man. To this is, I'll try to be a bit louder without this. Oh, okay.
Just hold it like this.
Okay. Ah. So this is where most of us are. We go start with a small prompt. You keep iterating. You just share your thought. It generates some output. It gives you what the LLM thinks. Let's pick a use case like you want to build a test case, right? You just give it tries to scan all your files. It gives you a plan like what it is going to do with it. You get biased with that answer, and if you're not convinced, you go fix it again. You keep iterating. So you do multiple iterations to get things done. But the problem is, I wouldn't say problem. It is actually a useful thing for quick fixes when you're trying to fix a bug, when you're trying to do a research, you want to do a POC. In all those cases, vibe coding is an apt use case where you can get things, do a quick brainstorming with LLM and you can build things. But the actual intent, what it lacks is uh, it is not going to capture the exact intent of what you want to build. You are not going to instruct in a very clear way on what you are trying to do when you are trying to build a larger project or trying to set up a framework from scratch. There are a lot of nuances that you need to capture. Those things will be missing in vibe coding. Vibe coding is for someone who's wants to do a research and do a quick POC. So you when it comes to enterprise ready or being injecting this into a enterprise process, this is where you have challenges with vibe coding because the consistency will not be there. One person, the vibe coding mode, the way the person prompts, everything differs from person to person, and you will not have the same scale. The person A who's going to solve the bug, the way it is being solved will definitely differ with person B. We all have experiences, I believe. So that's where, okay. So this is again, I touch base now, like why this is good for exploration, because you get quick answers, you can do quick iterations. But you don't need to be really clear with all your requirements upfront. When you are having a vague idea, you can start from there. But the problem is scaling and controlling. You cannot control the set the boundaries. It will just, if you want to build a order management system, it might go build so many other things that is there in all the order management systems out there. So that's where the scope creep happens. Yep. Yep, these are some of the things we have already seen. So risk of being implicit knowledge, it doesn't, you are in an exploration mode. You are not very specific with all your requirements. That's where it assumes, it fills all the gaps. Wherever there is a vague input, it tries to fill in. So the risk of deviating from your actual intent is much more higher with vibe coding. So that's where prompt engineering can help you with structuring your thought process. I just want to ask a question, like when you see prompt engineering, how many of you have actually experienced this or have been doing this? You know what prompt engineering, guys, it's okay. I mean, even I'm at a learning phase, so it's okay to talk. Yeah. So here's to the point. So I can skip that slide, I guess. So basically, that's what prompt engineering is. You have to put a structure to the prompt so that you can drive LLM on what input it has to, I mean, what output it has to generate, rather than letting LLM guess and drive you. So that's where prompt engineering plays a major role. The disciplined practice of designing clear, structured instructions to guide AI behavior, transforming AI from, this is very important, from generic responder into a controlled engineering collaborator. So if you construct your prompts in a way that you can let your intent clearly, you can set the boundaries, you can set the constraints, then you can see the clear difference of how AI is responding to you. So that's where it becomes very, very interesting. So these days, I spend a lot of time on this part. I don't start with writing a prompt immediately. I go sit, write a very clear prompt. I have an example also, like that's a handwritten prompt on how I solve one of my tasks. So it's very, very important and critical for you to understand why we are talking about this. Yes, prompts, it's basically the specs for the model. Like how we are talking about spec-driven, it is a spec that we are sharing with the LLM. So it understands this specs and it is going to respond based on what you are giving as an input. So LLM doesn't read your mind, yes. So you have to put all your recommends there as a prompt, else LLM will come up with its own assumptions. It is going to reduce ambiguity, hallucinations, and wasted iterations. As I said, if you are clear and if you are setting all the constraints, yes, it is going to do that. And prompt quality determines correctness, structure, and maintainability. And this is the first step in SDD as well. So if you want to adopt SDD, you also mean to have a very structured prompt. That's what the specs are all about. Yep. I'm just sharing an example of what a robust QA prompt will look like. Few structure, these are some of the keywords: role, objective, context, inputs, constraints. These are the keywords that LLM will be using to guide the output generation. So you have to be very precise, or at least try to match what your intent is with this structure. You can go give it a try on constructing a prompt this way and see for yourself. So basically, when you're talking about role, you have to set a role on according to the task that you're trying to do. So here, one example is you are a senior playwright, Cypress, or test QA engineer, which means that you are going to bias the LLM's output based on this role. If your task is more towards automation, if you're talking about if your task is more about research and development, you can set the role as architect. If you are a junior engineer, you can set a role at junior engineer if you are only trying to fix a bug or trying to write a simple test case. And you have to be very clear with your objective, what to build, and why we are doing it. So if you are giving that as a context, it again sets it right. And you have to give all the inputs, like whatever files you need to share with that in a very structured format, or any rules you have to give, any instructions you have to give, you can give it as a input. And constraints. So constraints is where you are putting a boundary to the LLM. Say, do not change this code, or do not read the files in this particular folder. So if you give such constraints, LLM will not do a scope creep. It will not go beyond the scope of what you are trying to do, and it will avoid it. Output format. Yeah. You can do that. So most of the time, that's also what I try to write a prompt and try to fine tune it with LLM. But the problem is, again, whatever problems that I talk about, right? It is going to fill in the gaps. Like wherever the LLM sees that it doesn't have enough information, it is going to fill in that. So you will get biased with that. So you can try that. It will give you a proper structured from prompt. You just write your problem statement and ask LLM to generate it, but you have to carefully review it before using it, because it will generate a very properly structured prompt, but you have to carefully review it. It will fill in a lot of gaps. Yeah, you need to review and correct it. You cannot simply use that. So quality checks before the output is rendered. You can also instruct how to validate the output that is being generated. You can add instructions for that as well. And rules, again, you can, so the example that I've given us, like do not generate any code. Sometimes I would like only to generate a file, a plan file. I don't want a code to be written all of a sudden. I don't want LLM to go modify my code immediately without knowing what it is going to do. So I can write all those as a rules. Okay, I have, this is actually a use case that I recently explored. I mean, a couple of my teammates are here, they know this very well. you put this as an example for you to give a clarity on of how I structure this is purely handwritten one. My objective here is I have all my test cases, automation test case, but none of the test cases are properly documented. So I want to reverse engineer and translate them into proper steps. So I could have easily started with a prompt. I have Windsurf. That's what we have at office. I can easily start with that. It has all the context. The agent has all the context about my files. It could have gone generated it, but I want to fine tune it. I want to make it more structured. I have a set of rules on how to give the output also. So that's where I sat and write down all my recommends as a proper prompt. Like I started with the role, like you are a test architect specialized in this, and I'm giving the context where I'm saying this is quality engineering team which has automated so many test cases. All the test cases are end user test cases. These are not exactly API test cases. These are at a system level. It is not at a component level, at a system level. So I'm giving that as a context. We have written these many test cases. I'm giving the problem statement also. The problem statement is that we don't have all these test cases documented well. So that's my problem statement. Need to reverse engineer the test case to generate test cases. My objective is scan the code base, identify the test specs of both UI and API test cases from different frameworks. That is the another challenge here. We have different frameworks. So use the reverse engineer to generate manual test cases in below QTest format. It doesn't end here. It's another two-pager. So these are all the inputs I have given. So I thought through that what all I need to capture here. So I mentioned like the repository has two different frameworks. UI test cases are in Cypress. API test cases are under E2B API folder. In most cases, my prerequisite is as part of my hook. And API test case have a test description as part of test annotation because that's where my description should be retrieved. That's one criteria that I've added. And qtest test case ID, because every test case has a qtest ID also. So I want to trace that qtest ID and map all the test case to that qtest ID. So that is an instruction for it. Each reverse engineer test case has to be mapped to a component. So I'm telling how to trace the component value from the key itself. Then I have given my file path like focus only. See, this is how I'm setting the constraint that I don't want to explore all the test cases. I have only a specific area that I want to focus on. So I'm restricting it by passing the folder path also. And I'm giving context about data-driven test cases as well and how to extract data points for that. Then another set of rules, what it should not do or what it actually should do. Do not modify any code in the report. Do not start generating the test immediately. I need to review the reverse engineering plan. I don't want to immediately let the LLM because that's a wastage of a lot of tokens. If it is going to generate all my test cases and I later realize that it has not done the right thing. So I first want to review what the plan is. So I have given that do not scan the test files from directories other than mentioned above. So these are all the rules, and output what I've asked is generate a high level plan to explain the reverse engineering process along with few sample reverse engineer test cases to review. So basically I'm instructing the LLM to generate a plan first and convert only few test cases for me to review so that I can cross validate. So once I review and approve it, it will generate. So that's what exactly happened with the prompt. I reviewed, I had few corrections, again instructed it, and I was able to generate like 600, 700 odd test cases in one shot. So this is a real example that it is all hand documented. One. So this tells you the importance of how to structure your prompt and how to drive the LLM rather than LLM driving yours. Okay, this is very critical in how you want to inject LLM into your enterprise. Like when you are doing your day-to-day work and you want to go AI first methodology, you have to have this intent of structuring your output first. Yeah, so but prompts also have limitations. We saw what vibe coding is. I can do much better with this prompt engineering. If I do the same vibe coding style, I can write a proper prompt like this. I can still do vibe coding, but the problem is it doesn't scale. I can, prompts are very transient. It works only in my conversations. Again, my style of writing the prompt differs from someone, my peer. So you will not have that consistency. So that's where the another challenge lies, and how prompt is also not scaling to what we want to do, like with the AI first, right? So that's where we want to get into a model where it works, it scales to all your engineers in the team. Like the output is consistent across them. I have a standard process on how do I approach my development. So that's where spec-driven comes into picture. Uh, Yep. So this mental model matters a lot. I know we have been working on, we all have been seasoned, working as engineers. We are seasoned with what we are doing for a long time. But this mental model shift should actually something that you have to take in. Rather than seeing AI as assistance to us to help with whatever we want to convert AI as a execution engine. So the problem with, let me sit for some time. Yep. So you have to get out of this mindset that AI will fill in the gaps. It will try to figure out the solutions for you. You have to master that. You have to set all the instructions, your intent very clear, so that AI becomes the execution engine rather than a assumption engine who's going to fill all the assumptions you have. So this shift is going to from problem diagnosis to redefining AI-assisted engineering strategies. Yep. So this is another. This is where the mental model shift should be. Like I should treat AI as a execution engine rather than assistance for me. So if AI lacks awareness of, obviously AI is going to lack a lot of awareness about your product history, what are the decisions you have made, what are the customer needs, the organization risk, about the small intricacies in your architecture. So most of this is not well documented. So at some point of time, AI is going to assume things. So if you're not going in a very structured way, in a very clearly thought through process where you document everything that AI takes as an input for you, until you go there, AI is going to assume a lot of things. So you set all your intent clear, structure things so that AI just reads them, assumes those artifacts as a instruction set for it, and it is going to simply execute what you are trying to instruct. So that's where the mental model shift should be. So considering AI, like most of the times what we do currently is like using this as an assistant, moving that from using it as assistant to assume AI is going to be your execution engine. It is going to only execute what you are saying, not going to deviate from your thought process. So that's what the shift that we are going to talk about. Okay, I'll pass here. I've spoken a lot. I've been rushing. So, any questions, any thought process, anything that you want to ask or share your feedback here? Yeah, gotcha. Okay, this is a question that has been asked more often because you have so many models available in the market, and what model should I use, and how to choose what model should I use? See, we can classify models this way. Like there are models which are fast thinking. You have been seeing right in the model option itself, which says instant answers, and there are models which have a balance of both fast thinking based on the context. It tries to get into a reasoning loop, and there are models that always reasons your thing. So the thinking models, right? They tend to do much better because what it does is like whenever a prompt is given, it tries to approach that in a very structured way. It tries to form chain of thoughts. It tries to see construct a step-by-step process on how to solve it. It doesn't immediately try to solve. See, basically LLM is nothing but it is a prediction engine. It is not. It does not have any imbibed knowledge, or it does not know anything everything about what is happening. It's basically a function that is going to predict the next token. So how that is going to predict is what these models differ. In a thinking model, what it does is like for the given prompt, it does not immediately try to come to the output. Like whatever I gave, right? It does not immediately generate the output. It first reads all the instructions. It generates set of prompts to question itself. So that's where it gets into a reasoning loop. So it generates what is my step 1, step 2, step 3. It generates a chain of thoughts. And for each of that, it tries to produce an output, then and some of the models have the validation loop also. It tries to validate the response for that particular prompt. So it validates, it checks the correctness of it. If the validation algorithm says it is not matching, it tries to regenerate. And that's how it goes into the reasoning loop. So when you are doing that, it for every prompt, it has a validation criteria. So until that validation is met, it tries to keep evaluating it, and that's how the thinking model works with the chain of thought process. So obviously that will have a difference when you are using a thinking model versus a fast thinking model, which might not go into this chain of thought process. It will try to immediately generate the tokens. So that matters, but how we want to choose depends on the task that you are trying to do, the intensity of the task. If you are into a research mode where you want to analyze your entire code base and come up with a new design, then obviously a better thinking model will be able to trace and map all the functionalities, try to build a model, a mental model within the LLM. Then it tries to go in one more step. Obviously, it can't do all by itself. Agent is in place. Agent will also drive a lot of it. But again, intensity of the task matters. For research task, you can go for this. For daily coding task, where you have the intent properly documented, all the instructions properly documented, you just want to execute, you can have a very balanced LLM to do that. And for more trivial tasks, you can use fast thinking one. Did I answer? I was a bit elaborate, but yeah. Yeah. So that's what we are trying all the while, right? Like how we want to avoid hallucination by properly documenting your intent. So the prompt that I showed earlier, right, where why I wrote these many rules is these are my Okay, so why I have written documented these many rules, written all these rules is I know my experience that LLM might assume all these things. It might unnecessarily go scan my entire repository, have inferences from those, and try to hallucinate wherever it doesn't have enough information to fill. So that's where I try and think and document all of it, what it has to do, what it should not do, set a clear boundary. And another thing which I missed here is I always ask these LLMs, I add one statement, please ask clarifying questions. So that way I can avoid assumptions. So these LLMs are smart enough that it tries to, all the thinking models, right? It tries to build a map, and wherever it has gaps, it will ask you all the relevant questions. That way also we can always avoid hallucinations. It can fill in all those assumptions. And one more thing is, as I said here, don't jump into coding right away. You just have to create the plan, like what exactly it is trying to do, how it is going to solve this problem. Review it. If whatever hallucination it has, you will be able to catch when you manually review the plan first. So that way also you can instruct, because you could have missed some of the rules. You would have gone and assumed certain things. So review that first, remove the hallucination, prompt it again, instruct the LLM to correct that part, then go ahead with implementation. Prachi was asking, you had a question. Yeah. Control token usage again. See, in a enterprise world, right? We are in a place where we write workflows, we write skills. It's a very detailed process where for every data, like if I want to generate my test case, I don't simply say go generate test case. I go through a workflow. So I have written a detailed step by step. What is step 1, step 2? How do I approach a problem? If you go in a very structured way, you will be able to assume, you will be able to clearly measure what my token consumption is, how I can reduce it. If you're going with a vague prompt, obviously you will go multiple iterations, then you cannot control that. So the answer to it is like you have to have a structured process in place so that you can, yeah, man. Hey, hi. Yeah. Still not clear on the question, but see, LLMs and agents agent is basically a tool. LLM is like a LLM engine, which is going to whatever token that you pass to it, it is going to generate tokens back. Okay, and most of the tasks that we do, whatever tools we use, we are using agents. We are like, be it Claude, be it ChatGPT, these are specifically agents. So it again depends on the clarity of the task, because agent how tries to solve is, it is going to, it has set of all the tools registered with it, but based on the prompt that you give, it is going to go with LLM. It says this is the user's ask. LLM knows all the context of what agent is capable of. Agent can read files, agent can make CLI calls, it can call a web service, it can do a database query. All is fed to LLM. So based on your task, it is going to keep iterating between, keep interacting between the agent and the LLM. So LLM says that I need more information, so go query a database, fetch this information. Then there is going to be a back and forth. So when this back and forth happens, obviously your token usage will increase. So totally based on your use case and how we are prompting it. So and how we are setting your prompts. Yep. No, no. See, with the plain test case generation, right? Because there is a lot of context in the web about native edge projects. Whenever I give a particular use case and ask LM to generate a test case, there's a lot of generalization, which might not exactly applicable to my product. It generates a very valid test case. When I root it, it will be very valid, but it might not apply to my product. So that's a level of hallucination. It is trying to generalize from what is there, because I'm not setting that criteria. Don't, this is what my product is. I'm not restricting the scope of my LLM to just to that particular document. I'm just simply giving hints that generate test cases. So the hallucination are at multiple levels. Again, with code generation, right? Code generation, most, see, again, agents comes into play. Some agents are very smart. It might have that level of capability to scan all the codes, get the context, feed it to LLM whenever it is needed, so that LLM can build a proper model of what your code architecture is. If the agent does that better, then your LLM has a proper understanding of your code, and it might understand the architecture pattern, and it will give you a proper if you are writing a test case, it will give you a proper test case that how you are already been writing. If that part is missing, then it will try to come up with its own design. So let's say your test case is always extending a base test. So your LLM might come up with an anti-pattern. It might not, rather than extending the base test, it might include all the methods in the base test in your test itself, in your test file itself. So these are the level of hallucinations. Like it can happen, like based on, it is all very case-to-case basis. But again, it's all about experience. But for your project, what happens? That's how you have to try to understand and try to write these rules. Yep. Actually, there are a lot of frameworks, available in the market on how teams can embrace spec-driven development. There is Spec-Kit, there is Kiro, there is OpenSpec. Each has different workflows. Uh, everything, whatever I'm talking, workflow skills, all are bunch of instructions to LLM. Those are structured prompts that we give to the LLM, and that is also how agent interacts with the LLM. So again, those workflows, some workflows are very intensive. Something like Spec-Kit, right, which is the product of GitHub. So all their workflows are very much aligned to GitHub workflows. Every task that you try to create with Spec-Kit is going to create a new branch, which means there are multiple tool calls that will happen. So that's how, and there is something OpenSpec, which is very plain. It has only certain instructions. It does not run through a lot of rules. It's a bit lightweight. So again, that consumption is a bit different. So it's again totally based on what framework you're embracing. You are also allowed to customize those workflows. You don't need to go through such an intensive process. So, but only if you put a framework in place, your process will be consistent across everyone. Uh, you have to do that research to see what works for your team. There is no one suggestion, because even within Dell, we are like exploring 3 different frameworks. Everyone has built custom workflows on top of that, and everyone is trying to sync. Like, but different workflows talks about the same spec-driven methodology, but in different terms. The terminology is different. The artifacts generated are different, but it works. And this is also a hot topic because we are very much limited on all the tokens and credits. So we are also trying to learn and see, try to associate each workflow, each process with a particular model so that we can optimize our token usage. Yeah. It will definitely have an effect. See, you in any agent, right? The entire conversation, we call it as context. Okay, what happens with that context is every time you prompt, the entire set of conversation is given to LLM. LLM is going to generate a response based on whatever that has been, both the user response plus the system response, meaning the LLM's response. So every time the entire thread is given to the LLM, it is going to generate. So as I discussed earlier, model matters. So some models go through that reasoning part, it gives a better response. When you are switching to a new model, based on the model's capability, your response may be better, response might not be better, but it will not lose the context. It is going to give the entire thread of conversation. That's how the LLM calls work. Every transaction, it is going to give the entire thread. It's basically predicting what is the next set of actions based on the entire thread. So did I answer your question? Yes, sir. See, agents have the capability. When you prompt, you can add these instructions as well if you want to have information from multiple repositories. So agents have that capability. It can go scan the files, feed that information to LLM, and LLM can build the context across repositories. But look at the cost. You're going to feed a lot of information. Okay, so to begin with, as an exploration part, you can do, but in an enterprise world, it's not how it works. Like that's where specs come into picture, right? So every project, like when you are migrating to a spec-driven process, what you will essentially do is the first thing that you do is generating the documentation for your project. That clearly tells you what your that particular web service is about. What is the architecture of it? What is the workflow? If there is a specific use case that you need to document, you'll document them as you'll clearly document them. And every project has a, see, when you're adopting frameworks, there are each framework has a config file. In OpenSpec, we call it as config.admin, which tells you exactly that's the first point your workflow will tell LLM to look into. So that config will have references to all these documentations. So which means that it's not required for the agent to go scan the repositories every time to understand. It has all the reference documents, the blueprint already ready. And if you are following the spec-driven process, every time you make an iterative process, as iterative change, as part of the process, once the change is completely built, developed, and merged to main, that baseline gets updated. That's an automatic process. That's the workflow that I'm talking about, right, in spec-driven. So these documents become our spec, which is a living document. So anytime you want to do cross-reference across projects, that's your thing to refer to. And see, we are going to implement spec-driven across, right? So all these documents will be in sync with whatever changes that is being done. I can talk more about in detail, like how multi-repository works, probably at the end of the session. Any other questions, or I'll move? I totally forgot where I was. Yeah. And again, I'm sorry, I've been repeating a lot of terms like intent, structure, all this. It might be a bit vague to you. I've not seen this in working, so please do ask more clarifying questions if you are unclear with that part. Okay, so far we saw what a vibe coding is, how we can get better with prompt engineering, and why prompt engineering might not scale at an enterprise level, because even if you write a very structured prompt, it is not going to give consistent behavior across team members, right? Even in your team, if there are 5 people, all 5 have to have the same consistent behavior, same consistent output. Only then you can rely on a 100%. So that's where spec-driven comes into picture. Spec-driven development is not a new terminology. It's not a new technology. It's a age-old practice. Basically, what it dictates is writing your specs first before going to implement any of it. That's what we have been practicing for a long time. The PM business analyst comes up with a PRD document first. They clearly document all their requirements first. Then that's where everything starts. In the waterfall model, that's where the PRD is completely reviewed, properly reviewed by all stakeholders. Then it goes to the engineers. Engineering is where they go look into the requirements. They come up with the architecture, the detailed design of it. Then from architects, it goes to engineers where they look into the high-level design. They come up with low-level design. They try to implement. So this is a age-old practice. But how suddenly it has become so popular with the AI is it has become so relevant for us to do make AI as an execution engine in this process. Because the first step is always clearly document my intent. It's not that I'm going to start writing code immediately. It's not that I have everything mapped in my mind and AI is going to execute. So I have to have clear instructions framed. So that's where spec-driven development comes into place, where the transient prompts and conversations will not help you with scaling. So here in SDD, we call specs multiple times. That's the common term that we use for different artifacts. Like artifacts you generate might be different. Developers might generate, architects might generate design documents. Developers might generate a low-level design or a plan document. QA engineers, they might design a test plan. But we all call them as the general term that we refer as spec. Spec is basically, I have a definition for that as well. Yeah, it's a structured behavior-oriented artifact written in a natural language that expresses software functionalities and serves as a guidance to AI coding agents. Okay, this is the key point. The way that you write and structure your spec, it should be a guidance to the AI coding agents. Like that's where you put all your governance and guardrails so that it does not do hallucination. Like what you have asking, right? How do I avoid? So when you structure it in a way that you look into all the loopholes, all the information that they might need to solve my problem, you document it, then your response will be much better and much consistent. You execute or someone in your team executes, doesn't matter. It will be much consistent. So what a good spec will look like, your good spec, you have to clearly, like I showed the prompt, right? You have to clearly define your problems, what the expected behaviors are, constraints, the assumptions that you yourself have assumed because lack of clarity, the risk that you see, the validation expectations, you document everything clearly as a spec. Then as a executable intent, this is what will guide the AI to generate the artifact. Like say, I have a spec document, which is a PRD document, and I give that PRD document to LLM to generate test cases. It tries to observe all the nuances from the PRD and it is going to generate. But it is not going to generate test cases just by looking at the PRD because PRD will talk only about that particular feature. But my LLM does not know other nuances of my product, right? What my existing test cases are, what my test plan will look like. Will there be any regression impact? Might not be there. So that's where the documentations, like Sham was asking, right? How do I handle multi-repository? Where we have to document everything that is existing. So all your documentation, all your guideline on how to generate test plan, how to generate a test case, if you have everything clearly documented, then you will get the intended output in the same pattern. Like it goes into a level where you even say what my test case pattern is, like what my descriptions, because there are multiple patterns, right? I can use a plain description, test steps, expected output, expected results, right? Or there could be behavior driven, given, when, then. So you can instruct LLM, you can give examples to it on how LLM can generate my test cases. Okay, how explicit specifications become a solid test artifact? Just now I was explaining it. So make the problem goal boundaries explicit before implementation begins. You have to be very clearly documenting it. You have to have a means to define your system exactly. So what my system is, how my expected behavior should be, what are the constraints I have in this, and the non-functional requirements, like what my baselines are with respect to non-functional, so that LLM can make that judgment on whether this particular implementation can go or impact my baseline numbers. So it can generate a functional, non-functional test case according to that. So once you give that, once I have my spec clearly documented, then AI uses, both AI and us will use that as a single reference to generate all these artifacts. I can generate a proper test plan. Once the test plan is clearly reviewed by me, I thoroughly review it. I understand what it is going to do for testing my feature. Then I approve it. Then that's what becomes the blueprint for AI to generate my test cases, because it is not going to generate anything outside of my test plan. My test plan says test this, it is going to test it. If my test plan is not covering it, it is going to miss that. So at every stage, the human role plays a very critical part, because your review is what validates saying that the intent is correct, whatever intent is. So if you are generating a document, make sure your peer reviews it, approves it, have a proper review process in place. Spec first evaluation changes are applied to the spec first, not passed directly into the artifact. So again, this is very, very critical. So whenever the common thing, right? When you're working on a project, there could be multiple changes coming in. Someone you have generated a spec for you. In our term, let's call that spec as a test plan. You have created a test plan. You are reviewing that test plan with your team. Someone has approved your plan. Now we are going to generate test cases with that plan. So we're going to feed that test plan to a LLM. LLM will generate all the test cases. Now you find some gap in the test case. The most instant thing that you want to do is go correct the test case immediately. But that's not how we should do. The right approach is to go fix the test plan, fix that gap in the test plan so that all the artifacts are in sync. If that test plan, fixing that test plan, which also means I have to go update my spec as well. The spec which is responsible for generating my test plan, if the gap is very prominent. So that's how you have to keep all the documents in place so that LLM always have that as a reference rather than breaking that reference chain. If you're going to update your test cases directly, LLM will not even know. There will be gap between the test plan and this one. I cannot cover or have a coverage between my recommends and that generated test cases. So that's where the spec first evolution comes into, yeah. Whoever is embracing spec-driven, that's how it is. So this process, the spec-driven process starts with PDM actually. So everyone has a role to play. So as PDM goes through the same iteration process, they generate a spec, which is called as a business spec. They hand it over to engineers. I'll cover that part. There's a slide to talk about what happens at each phase. But yes, that's what it's going to be. Yep. So that's what the spec has to be an executable intent for AI. So why we are putting so much effort on generating a proper spec, because it does not want to infer missing intent. So it has to execute only what is there in the spec. So clear specs enable consistent generation. It will be consistent because irrespective of who is going to execute that spec, it is going to be consistent. Sometimes even the model also, similar models will give similar behavior because the instructions are very clear in the spec document. Without specs, yes, AI is going to guess. So your consistency will be a big question mark. Yep. Again, deltas. So there will be changes coming in your way at any point of time. Who are in agile model, this is not a new thing. Whenever you're working on a product and you are in mid sprint, suddenly your PM says that there is a change. You might have to capture that. So how that works in a spec-driven world is that, yes, again, you have to go through the same process, go update the spec, then update all the artifacts that is used to generate the spec. I mean, that the spec is used for generating the artifacts. Meaning, while updating, what you should do is you should not replace the entire spec. If you are replacing the entire spec, I see so many faces clueless. Are you guys able to follow me? Okay. Okay, I have a quick demo to show what a spec is, what spec captures, and how a plan would look like. Probably I'll go to that part very soon. Okay, so when I'm talking about a change in the spec, right, meaning I got a new requirement, a new change, like instead of a drop-down field, I want to change it as a plain text field. When that change comes in from PDM, right, PDM is not going to rewrite my entire spec. Meaning if he is going to rewrite the entire spec, the spec content will change because there is no guarantee that LLM is going to generate the same set of words. So which means that my spec has changed. My spec will create like 10 different requirements this time, maybe meaning the same thing, but the wording changes. So there are chances that there could be misalignment. So based on that requirement spec, my design has to get updated. So which means that design also there could be chances to that there will be misalignment between the spec and this one. So how we should handle is all these changes should be written as a delta, like a change log. Like this was my original recommend, this is the additional recommend. I only append it to my spec. I don't, unless it is a huge change where the entire feature is changing, I will not regenerate my spec. The spec will always track this as a change log, have this as a section so that I have a corresponding feature recommend created for it, and that recommend gets mapped to a design change, and from design change it goes to a particular test case or particular implementation, code implementation. So that is very important. You don't really need to rewrite specs. You have to keep adding the deltas. So this also we spoke like why we need to keep all the specs relevant, because if the specs are not relevant, it will. So what happens, like as Shyam was asking, this spec is what is going to talk about what the feature is all about. So every time when a PDM comes up with a research phase to implement a new feature, he is going to refer these specs, which is going to tell you the current state of the product. If that spec is not properly documented, if that spec is having gaps with what is already implemented, then you will lose that intent. You cannot use those workflows to generate a new product because the spec is not reflecting your current product. So it is always essential that you keep the spec relevant, keep updating it, and once that change is done, you go back and update the spec, the baseline spec, so that every time you have a prototype saying that this is what my current product is. No, no, actually, this point, right? It is purely based on how your operating model is today. So how your operating model is, because these are roles that you can define in this spec-driven model. You can have a automated quality gates put in each phase, like who is going to generate that PRD document, who is going to review and approve it, and who is going to own the next part. And you can put a quality gate saying that without approval from these, or when I say approval, it can be anything. It can be a, LM generated context in the file itself, or a GitHub approval, or a PRO. Will Yes, yes. Yeah, between business spec and the engineering spec, right? Meaning the architecture document, right? You can put all that quality gates. Each one has a role. Like we call it as proposal. That is the PRD document. That is owned by PDM. And the approvers, we have a standard list of approvers who will review and approve it. So we have an architect in place, you have an engineering lead in place, you have a QA lead in place, who will go review these documents and approve it. Only if the approval is in place, I'll be able to move to the next phase. These are automated quality gates. You want to save cost for your company, or say PDMs will have this question now. And that's what my PDM said. Like, I can do everything himself. No. See, the very essence of spec driven, right? You document everything. Roles are I mean, the importance of the role are minimizing a lot. Like, you don't necessarily need a QA lead to generate that document, or a engineering, because you have all the instructions clearly documented. What my architecture is all about, what my guardrails are, everything is clearly documented. So LLM is going to abide by what it is documented. The only place where we need the SME is to review it. And as we move towards, we are automating the review process also, which means that that gap is also minimizing. So roles doesn't matter, but still there is a huge necessity for the SMEs because they know the in and out of the products. That process is different. Yeah. Yep, I'll try to rush. So this is the typical life cycle of what a spec driven will look like. You start with a spec, where spec is where you put your intent, you put your requirements, properly documented. Then the next phase in the life cycle is you come up with a plan. That is where you strategize on how to implement it. So you create a plan. Plan exactly tells you this is where the design. You can associate this with the design document. It will tell you how to implement this feature, what code I need to write, what is the client I need to write, everything about design it talks about here. Then task. So now I have the recommend, I have the plan generated. Now how do I implement it? Like what is the first task I need to do? What is the next task I need to do? Sequence of tasks. Depends on the dependency graph also, like because I cannot execute all at once, right? I have to have, so there will be dependencies. I need to write the client first before I write my test case. So all this will be defined in the task. And the last part is implement. Implement is where you tell LLM go implement this particular task, and it will implement. And you also write a validation task that will generate test case to validate that exactly. And if you look at this part, right, where the spec goes to multiple iterations, like every time I review it, it goes through a update. Okay, sir, we'll done. We'll be done soon. Uh, so this is the loop. I mean, this loop can fit in any of the process that you are following today. But to give a more detailed look, like this is AI generated based on my instructions, so it might or might not fit into your company. But this is how a spec-driven is aligned with SDLC. The first part, this is the human part, where the discover or define part, where every problem is properly documented, the problem statement is properly documented, the business requirements are gathered, and they use LLM to generate a proper specification document. So the first part, coming up with the raw requirements, is what PDM does. That is a hand-driven one. Everything else is all documented by LLM. So that is where you will keep all the documents in sync. So the next part, where the specify, that is where you generate a proper business spec. Business spec is again set of prompts in a properly structured format. Again, the engineering spec, where it is going to talk about your engineering requirements. For me to implement this feature, what all changes should I do? What is the new API that I need to build? Or if I have to modify an existing API, what is the change that I have to capture? So that level of spec will be generated here. So again, you might have the question like how this engineering spec is generated. It is again going to be based on all your architecture documents. So that's where all the baseline documents come into picture. So LLM is going to take this business spec as an input, and it will have references to all the existing architectures. So when the user requirement says that I want to add one field in, I want to capture address for a user, then it means that it has to update the user, create user API. You get it? Like in a user form, I'm going to add a new field to capture the postal code, which means that the corresponding API has to be updated. So that's what the engineering spec is going to capture. It says in this user API, go update this field. So that level of engineering document is generated. Then the corresponding system test spec. So when I say system test spec, it is where your test plan, what your customer journeys are, what your scope, what is not in scope for testing, what is a functional requirement, non-functional scope, like do I have to do a performance testing? So all this will be captured in the system test spec, and the non-functional expectations, like that is part of the system test spec as well. So that happens in the specific part. Then the plan and design phase, where these documents goes as an input, comes up with a high-level design, the implementation plan for test team. It is a test plan. For automation, we create an automation plan. Then the task breakdown. Then the next part is where you build. It is all about implementing the task that is generated. You go tell LLM that implement this, which means that it could be for developers. These are source code generation. There could be unit tests, component tests written by them. It can also generate documents. For us, it is all about writing test cases, both the manually documented test cases and the automation test cases. So that's the next phase where we validate, generate these test cases, run them, and validate. And the execute and release phase, right? So if you look at this keyword, right, artifacts, basically these are the output that each phase generates. So, and these are all properly generated by LLM based on the guardrails and the rules that you have set. And even for all these documents, you generate a template document, meaning that this is the template you should generate this particular test plan every time, so that you have consistency across features. So that's the output that you get at each phase. And feedback and evolve, that's where you actually execute and try to share the feedback, and it goes through the loop. It's just a demonstration of how a spec-driven development gets aligned with the SDLC. Your team process, your team artifacts might be totally different. You might generate artifacts at different phases, same set of artifacts, but at different phases. This is just a demonstration to give you a view of how SDLC will look like. I mean, SDD will look like. Yeah, I mean, I don't want to repeat this stuff. Like we have spoken about what spec is, why we need such a strong spec, because that becomes our contract for LM to say what it has to do. It has to. So the main intent here is we are not going to validate based on the implementation. We are going to validate my product based on what my spec is. My business spec, that becomes my source of truth. So the business spec that is generated here, right? The same business spec is what engineering team will use and the quality engineering will use. That becomes our single source of truth to generate different set of artifacts. So we are going to validate what is there in the spec. not what is getting implemented. So that's where I maintain quality. I can find gaps in the implementation, and I can fix them early. Yeah, governance and guardrails. Like I'm not sure how many of you are aware of these terminologies and why they matter a lot here. Because so many questions have been raised so far, like on how do I trust the output, how do I ensure there is no hallucination, how do I ensure who wants this, the process about who is going to approve it. So that is all defined as governance and guardrails. Basically, governance tells you how do I generate all these artifacts. It's more like a guidance on how to generate each of the artifact. And guardrails is more like a quality gates that I put in place to ensure that it is not going beyond my scope. So why governance is critical in AI-driven QA? Because AI is going to accelerate all the artifact generation. Like within minutes, it is going to generate a spec document, test plan, test scripts, utilities, and helpers. Without governance, these are the problems you'll have. Like you will have a plotted coverage, because if you don't set this is what my scope is, as I said, it is going to get all the information from the World Web, and it is going to fill the gaps. So if you are not restricting, or if you're not having a proper product document on what your existing product is, there will be hallucinations. So my governance is always refer to my existing test cases. That's how I'll write a governance rule, that always go refer my existing test bed to analyze my regression impact. So that's how I can write governance. And for flaky automation, my governance would be, I will write all my rules as best practices, like what all best practices I've been following. Like for the API calls, if I want to assert, I can have a separate conditional weight criteria. I might document that as a rule on how to write conditional weights. That could be one of my governance. Design inconsistencies. So I document my architecture, my exact framework design pattern as a document. And in the governance, I say that go review this before suggesting a new change. So this should be the guideline for you to suggest any new test case. So that's how I set all my governance. Governance principle, behavior first, spec before implementation. So that's what we were discussing. Like don't go with implementation first. You always generate a spec document. That should be the rule everywhere in the spec driven. You have to have a plan, artifact generated first, review it, then go ahead with implementation. Design integrity, just now I spoke about it, like architecture should remain consistent. So how do I ensure it? That is also a governance aspect. Quality gates and accountability. So accountability is where, how do I trace all the artifacts that I generated to the business spec, all the way from my automation test case to a business spec. So that level of accountability should be established by governance. And talking about guardrails, again, this is how we should. So these are all basically it's a thought process on how do you implement core guardrails. It is not exactly what core guardrails mean. When I say no artifact generation without approved spec, you should put a rule saying that, like I said, right, without a proper GitHub approval for a business spec, I should not generate a design document. If I have to have that as a quality gate in my process, else anyone can trigger that workflow, generate a design document, and go out with it, which means that which is disaster, someone might miss a requirement also. So that's where guardrail should be in place to ensure the proper approval process. The strict adherence to the template specs. So again, I said, right, I have to have templates. For all the artifacts I generate, I should have a template document, so that every time that workflow is going to generate a test plan, it will generate the same test plan following the template. Meaning this test plan, all the test plan generates follow the same template. It has same in scope section, out of scope section, risk, everything will be documented. If you don't have a template, every time your design document will be, your test plan document will be inconsistent. Sometimes it might have some sections, sometimes it might skip. So that level of guardrail should be defined. AI generated or treated same as human generated. Yes, you cannot simply assume that it is AI generated. So you have to have a proper review process in place. You can nowhere blindly copy paste what is coming out of AI. It has to go through a proper review process. So that review process should be dictated by the guardrails that you set in the project. Reusable standard prompts, clear audit trail in commits and PR reviews. Like if you are following a proper GitHub workflow, then you can capture all these guardrails through the commits, and you can approve it through a commit with a commit message, or with a PR approval commit message. So that's where guardrails come into place. Okay. Again, same repetitive stuff, like what are the quality gates that you can put in place? These are all automated quality gates that you can put, driven by LLM. So you can have a pre-commit lint, formatting checks, static analysis, which will also solve a lot of your problem. And coverage thresholds defined, but tests, you can always instruct that the test should be passed. Like LLM can trigger the pipeline, which can validate the test results, and it can promote that document to the next level only if the test is passed. So you can have such level of validations in the quality gates. And the most common review model that has been suggested now is to have a 3-layer review model. So have a checklist for you to do a self-review, create a checklist. It is again case-to-case basis. What you need to do a self-review can be defined by your team, get it reviewed, then automated review. Some of the things that I mentioned before, right? Like static analysis, format ejects, that can be made as an automated review. Then peer review, when your peer reviews, what he should specifically look for, apart from what you have done as a self-review. So you can define this three-layer review process, and there should be a lot of emphasis on the review process because the artifacts are generated by AI. So the main role that human will play is validating the documents generated by AI. And another most important part is the traceability, because you should be able to trace why this particular code is generated. If you lack that traceability, you will not be able to find, because too much of code is being generated. So I should be able to associate a particular piece of task executed to a functional requirement defined in my business spec. So you have to establish that traceability. Okay. Yeah, so this is the practical QA workflow, how you can start. Basically, put your thought process, start with a proper intent. I don't know, should I pass before I go here, ask questions, or just move on? We are getting late. Sorry? I not exactly a demo, but I can share some artifacts that are generated. Maybe that might give you some sense. I thought I'll do a full-fledged demo, but I couldn't. Sorry. Okay, how you can go and get started? Even today, you can go experience this. You don't need to have a separate framework in place. You don't need to have anything in place. All that you need is some powerful agent and good amount of tokens for you. Go start with the feature intent. Let's say if you are working with test automation, go have a clear intent document like the prompt I showed, document it, but your intention should be to document, generate a spec, not the code. So go generate a plan with it. So what plan is like, if you are automating 5 test cases for user API, give the exact API details, give the recommend of how you want to automate, and it should also have understanding of your framework. So the prerequisite for this is to generate a baseline document for your framework, meaning what your framework is all about. So your framework might talk about page object model. Your framework might talk about how you handle multiple threads. All this you can document, then start with generating a spec for you. Clearly write all the recommends for your use case. Then instruct LLM to generate a spec. Once the spec is generated, you go properly review it, see what you want is exactly reflected in the spec. Then do iterations to fix it. Once you are clear with the spec, then ask LLM to generate a plan. The plan document will exactly tell you what all code changes it has to make to implement these 5 test cases. Then you can go review that plan. The next part is implementing that plan. So you can right away go explore that part, but just try to follow a properly structured format. You can be a vibe coder just to generate this. So this is what we saw. Like come to the end of the session. Like basically, the key takeaways is uh, the level that AI is going to amplify the clarity or the productivity. The same level it is going to amplify the error as well. So you have to be really the clarity in your intent should matters a lot. So whenever you start with anything, you just put your thought process first. Spend your time there, document all your thought process, then go ahead with prompting. So that's what matters a lot. Then we saw about how vibe coding could be limiting you in terms of scaling to your team, how to while setting this as a process. Then we saw about prompt engineering, how you can structurally write your prompts, which is a very effective process practice. I really recommend. I can share that slide with you. You can practice that. Try to write very structured prompts and see how it works for you. Then we saw spec-driven development and how spec-driven development can scale in a large enterprise model. So this is what I wanted to cover today. Any questions? I know this is a long session talking more philosophy than showing real code. Sorry for that, but I hope I made some sense. I'm not able to hear you clearly. Okay. See, only measurable benefit that we are trying to evaluate at Dell, right? I have never worked in a banking industry, so I cannot comment. But what we are trying to see is, like you said, the productivity and the quality part of it. So currently, how we have structured our team is like we have formed small pods. Each pod is like a very few developers being part of each pod, and that pod is taking care of a capability or a feature that used to be worked by like by a 10-member team. 10-member team across multiple teams actually, not just one team that gets involved, multiple teams now that are shrunken into a 2-member or 3-member pod, which is going to wholly own that product implementation. And the target is that we deliver, including testing, we deliver within 2 weeks. So where these capabilities were worked upon in a span of 3 months. So that's the scale that we are trying to reduce. This is still in progress on how better we get with it. That's the measurement we have put in place on how good the pods can meet that deadline, like 2 week target to begin with. But the eventual goal is to do that in 1 week. So, but again, that's how we are trying to measure the in terms of productivity, in terms of quality as well, because that's the main criteria. As we progress more, we generate a lot with the AI. We cannot compromise on quality. So that's why quality also gets a lot of traction here. My VP said there should not be any QA engineer sitting in that pod. So we were concerned like if there is no QA engineer going to be part of that particular pod, then how will we validate? But that's where his immediate response was write a skill. So what a QA engineer does, it has been translated into a set of instructions to LLM. So basically, my thought process, my product, my tribal knowledge, everything is translated into a skill, and that's what we share it with the pod workflow. So whoever can execute it, they will actually go through the same thought process that we go through, and we are getting better. It is not going to replace it immediately. We are getting better at it, but that's what we are looking at. That's one aspect of it. What is the other question asked? There's a lot to it. Even the demo that I'm showing here, or it's just a bunch of files that I want to show you. Because I've been talking about spec, I just want to show you what a spec would look like. Font size. Yeah, one more. It's just terrifying, but look at the flow speed. Now think about what you can. Now you can build apps. You have an idea. It will be easy for you to build apps. Now you are no longer just stick to only custom here. So find out a problem statement, find out a solution. Build more on the problem. You can do that within your company, outside your company. You can do it by yourself. You have a great idea. So you don't need to know how to write the code. You just tell the prompt that, okay, follow what that. See, I generated.
Check.
Okay, so this is the spec I generated for order creation. It's going to talk about what I would do in the order creation API. So it says what the scope is, happy path order creation. Because I'm limiting the scope of order creation just to happy path, I can go multiple iteration, create a new spec to add more features to it. But for a demo, I just did this. Here it is talking about the request, the response, basically the contract of the API, and field rules, what each row, each field should do. Is it a required field or not? Like what is the type of it? Everything is documented in here, and the acceptance criteria. So ideally, this level of document will be generated by a architect. So the magnitude of this feature is very small, but in real world, the use case will be much more complex. The engineering lead will use the business requirement to generate this level of what I've generated is a test plan for us. This is the QA artifact. The corresponding engineering artifact would be a plan document to implement it. This is the test plan document which tells you how to validate this particular feature. So this is going to use the same engineering spec that was generated. So it is going to validate all the API endpoints. It has written test cases here based on the recommend document. And it also gives you a traceability matrix that I said, right? Like what test cases are going to validate my features that are there in the spec document. So that level of traceability. So when you review it, you can even automate this part where you can always ensure that there is test case written for each requirement, or there is a coverage for all the requirements mentioned in the spec document. This is LLM driven only. So the third part is the task breakdown. So basically, this is where it tells you what are the tasks to implement my plan. My plan has given like 5 or 6 odd test cases to implement, to automate those 5 test cases. How will I do it? So that's where the task comes in. My first task is about creating the pom.xml because I'm starting something from scratch. It creates a pom.xml with these dependencies, residue, testng, all these dependent libraries. The next task is to create a testng XML because it is a testng based. The third task tells me to create a order API client because I'm going to call that API to validate. So the instruction is to create an order API client. Then the fourth task is creating the data object. And fifth task is creating the base test. So because I want a base test which should be extended by all my test case, right? That's the first set. This is group test infrastructure. Without a basic infrastructure, I cannot build my other test, right? This is an example of implementing automation from scratch. The next set of test cases is about implementing the test cases. All the tasks like task 6 to 10, it talks about implementing different test cases. And I have 11 and 12, which is going to validate my implementation, which is going to validate my own code by running the test case automated. Okay, and this is the traceability matrix and how the tasks are mapped to the test cases. Now all that I need to do is go tell LLM execute task 01. So basically my LLM is going to execute exactly what is defined in here with reference to what has been mentioned in the plan. Okay, so all that I need to do is simply instruct LLM to execute all these tasks. We can do it in one shot. LLM is smart enough that it can go phase by phase. It will first execute the infrastructure task, then it will go implement all the test cases, and it will do a validation also. So that's how it's a very quick demo. Sorry, I couldn't get a very elaborate. I thought I'll generate spec in front of you and show you, but I couldn't do that setup. But I seriously recommend this is the plain process. You don't need any specific tool to do that. All that you need is the agent. Go have a specific use case. Before you start with it, try to generate documentation. Documentation is basically a reverse engineered document. Reverse engineered document as in it goes, scans all your code base files and generate a baseline document for your framework or your test repository, which tells you what is your framework, how test cases are written, all the documents and the rules also. What is your branching strategy? What is your how you structure your commit message? Everything can be documented there. So have that as a document. Then in the prompt, say this is your use case, you want to automate this. You can instruct LLM to refer this documentation to come up with a plan, and you generate a plan. Once the plan is generated, go review it. If it is not aligned, then you will find the gap. Then again, either fix your documentation or fix your prompt. Go generate a proper plan. Once the plan is generated, then again instruct to generate a task. So task is something like this. It will tell you what, it will basically dissect the plan into multiple smaller executable unit so that you can execute it one by one. So this one you can go try right away for any of your use case. Just share your experience. But the more advanced part is something like Spec-It, or probably I can show. Mm. Okay. Yeah, actually, see, wherever you see a gap, it's because our instructions are not clear. Somewhere we need to fill it, structure it. So, Spec-It workflow. Just want to give a quick. Let's see if I can find some image. Okay. Ah. So this is Spec-It as a framework that helps you embrace spec-driven development. You can go read about it. It nothing but it has automated bunch of workflow. When I talk about workflow, right? Workflow is a step-by-step process. Any process, right? Let's talk about test plan, right? When you want to create a test plan, what is the step 1 you do? Step 2 you do? Step 3, step 4. You just clearly document it as a executable instructions, and you automate that as a workflow. So many all the agents, powerful agents, help you define workflows like this. But in Spec-It, they have already defined these workflows, which can be generalized and used it in any place. So here there is a phase called /specify, right? What exactly it does is, it is where it will help you generate a spec. It has bunch of instructions written that helps you automate the spec generation process. So in specify, you go give your recommend, it generates a spec. Then in plan, if you go give your plan, it will generate a plan based on the specification. And in task, it will generate the task. So basically, these workflows are automated prompts, is what I would say. So you can go explore this one. This can be, this is how all companies are moving spec-driven in a more structured way. They embrace frameworks like Spec-It or OpenSpec, or even they customize these workflows to meet their need. So these are some additional things, but we can have a detailed session on these workflows as well. Any questions? Thanks, man. Thank you so much. Brownfield, as I said, you have to see greenfield, it is very straightforward. Brownfield, as I said, you have to do some tweaking, you have to generate all the baseline documents, but it's not difficult. You can get started because most of our projects are brownfield only. So we were putting that effort to ensure all the documentation is in place. The thing is, you cannot document everything. You have to capture the nuances. You have to get better with it. You have to experience and do that loop few times. But that baselining matters because you cannot let LLM explore the entire code base every time. Yeah, you have to. So you have to, that's where templates, I said, right? Like you have to have a template. In that template, you can have a section for change logs where you can capture these changes so that you have a track of why this particular change has come, who has triggered this change, and what is the implication of it. so that you are. So sometimes what happens is you have a business spec, you have a plan document, you have engineering document, so many documents, right? When the spec is changing, when a PM is making the spec change, it's not always true that all the documents will be updated, because it is manually triggered and owned by so many different stakeholders, right? So how you will know that your document has become stale? You have to have some means in the spec to show that there is a new requirement added, so that I can go catch up with it. So without that change log or a way to capture that, it is very difficult for you to keep in alignment with all the documents. So you have to figure out the mechanism for it. It can be done in multiple ways. Yeah, yes. Yeah. So are you asking this as a question or mm, yeah. See, what I'm trying to give a context today is how you can scale this. Scale the prompt engineering technique might work well for you, but not work better for the other your peer. He might not have always put that effort to structure that prompt. So we are talking about how this can be scaled and how we can maintain consistency across all your teams. Because you're talking about enterprise which has 10,000 people. So you have to have that consistency across everywhere. So that's where all this, the spec kit, everything that I showed, right? So you're establishing a process. Yep. Any more question or we can end the call? Yep. Thanks, guys. Thank you so much. Yeah.
Yeah, first of all, I think Sabri has tried to work a lot on like to bring this as a content about 40 over slides. I'm sure for some of you or most of you, it might have been overwhelming. So please take some time to process it, and please reach out to Sabri Async if you would like to on LinkedIn. He's also there on the Tequila SG WhatsApp group. You can reach out to him as well. First of all, like, can we please have a big round of applause for Sabri? Because whatever we got to see today, I'm sure that must be the tip of the huge iceberg that is there. So if you're interested, and because a lot of us want to do AI-driven workflows, but in a more structured way, right? So personally, I see spec-driven development to be one of the potential uh, approaches where you can better structure it so that you can apply it in your day-to-day life. So Sabri, if possible, please get us a GitHub repo or a video. Video would be great to show it end to end, like how it works in action. I think that would give us a better picture of it. And lastly, but not the least, thanks to all of you for making time on a Friday evening, regardless of how the week has been. Thanks to you all as well.